Hello, Professor. This is Sri. Today we are going to give the final presentation of the DotaAnalysis project. And today's agenda is we are going to give the updated waterfall checkpoint model and the wall of work of ours, which is in ZenHub, and the final demo. So the wall of like the work breakdown structure from the waterfall checkpoint, I have updated it, and the green dots are the ones which we have completed, and this is a screenshot of the WBS. The next thing, the NAT chart from the work waterfall model, I have updated it and all the dates. So our project is like 100% complete now, and these are the tasks we are done with. So this is all the tasks we are done with in the completion of the project. This is the end point here, the closing of the project. And the next thing is the wall of work in the ZenHub. So I have a security issue before, like which was in the icebox. So I have moved, I have closed it, saying that it's a future enhancement of our project, and this feature will be applicable even like if we want to do encryption and for secure maintenance of the server. And all the other features they are already done, so I put them in the done column of the wall of work. So this is our wall of work, and I'll post this link in the assignment shell so that you'll be able to view it, Professor. And now over to Praneeth, Professor.
Good morning, Professor. My name is Praneeth. I'll be going through our backend. For our backend, we're using MongoDB, and in our backend we have a couple of collections, in which one of the important ones are heroes collection that holds the ID of the hero and name of the hero, and then we have a records collection which basically has the team with IDs that won against the team with IDs that lost. And then using these tables, we have a servlet, Java servlet that runs. And Java servlet basically consumes all the API calls. API looks like this, in which you can give an array of my team and an array of opponent team, which then uses the database and gives suggestions of the top 3 best heroes that he can pick. So I've just executed the API, and we have IDs. First one is basically the hero that has highest chances of winning, and second, and then third. And then what basically happens is that in the code, first it gets all the teams that won against that particular combination in the API, and then the second step is to get basically a collection, like the ID of the hero one was like selected one time in this collection, and then 3 was repeated 3 times, and then we have a filter that finds out the ID of the hero that was repeated the most. In this case, it's 13. So hero 13 was like 43 times of the occurrence. This hero won against the opponent that's pudged in this. And then finally, once we have that, it filters out the top 3 suggestions and then gives out as an array to the front end. Apart from that, we have some other codes for visualization, data configuration. This is the configuration which consumes the API calls, and we have classes that actually deal with the connection to the MongoDB server. And then this is kind of like ETL code that puts in raw data. We also have a raw data dump. That's the Dota dump, which we use this code. This code basically uses that particular collection and then records something like this, which is easy to read and process. So that's how the database works. Using this, our front end consumes the APIs and runs on it. And now moving over to Anurag. Thank you, Professor.
Hello, Professor. Anurag here. So now we are going with the front end. This is the code for the front end. We are using PHP for the front end. I have installed WAM server to run the PHP. Where I'm running it on a local host. So here this array is for all the heroes. All the heroes are included in this array. Then we have variables and global variables for handling uh, the form actions and sending the API calls. Here you can see we have an API call to send call to the server with various heroes. You can see this is the first hero, second hero we are sending. So basically we have three calls. In the first call we'll be sending four heroes, two my hero and two opponent, and in the second API call we'll be sending six heroes, three of each team, and in the final call we'll be sending four of my team and five of the opponent heroes, and I will be getting the fifth suggestion, final iteration of suggestion. Now let's get going with the actual functionality of our project. So Professor, this is front end. As I said, I'm using the WAM server and I'm running on the local host. So when I open the project, this is a basic interface, a simple interface. Now in the hero select interface, we have four heroes to select in the first iteration. In the first iteration, I select four heroes, two for my team and two for the opposite team. Then I press the submit button. Then just for verification, we said we used response OK in the code, so that we want to know that the actual code is working and API calls are working. So here we get the suggestions as Husker, Batrider, and Weaver. So now in the second iteration, I send one more hero, two more heroes, one on each side, and I press submit. I'll be getting again a response OK. I'll be getting the next iteration of suggestions. Here Bounty Hunter is the top suggested hero for my fourth pick of the Radiant. So now again I go and pick the remaining heroes. Then I submit. Then I get the final iteration of suggestions: Lena, Juggernaut, and Brumbringer. So with this, I think the project has complete functionality. All the suggestions are given with the inputs given, that is the heroes given, and um, as I say, these three suggestions are actually the top picked, the top suggested heroes. Here, the Lena is having the highest win rate with the above combinations, and Juggernaut has having second highest win rate. So this is how the this is how the our project basically functions, with the API calls on the back end and PHP and form in the front end.
Hi again, Professor. So we have done some basic visualizations using a Jupyter Notebook, and so I have done a heat map first. Like this is the test CSV. We are making the projections and all on this thing. Like this is the test data of the JSON file we have, and this is a heat map. So it has every column of the CSV file, and the next one is a line plot between experience collected per minute and gold collected per minute. And the next graph I did was just the scatter plot, which has levels of the player and experience earned per minute. So the next one is a histogram just stating the gold collected per minute and its frequency. So these were the basic visualizations I have done with the test CSV. And the other visualization we thought of putting in the site was like projecting the major cities in which the tournaments were held on a world map. So I've used base map for it, and I have run the Python code, and this is the result I've got. So this is the world map projection I've got, and it states that major cities of Dota 2 tournaments, and these are the cities. Like I have a red dot at the projection stating that that's this state, and I've coded a code for getting this text in a yellow box over it. And here by using this, because we are using the base map of Matplotlib, using this magnifying glass, we'll be able to zoom it. So I can zoom in and uh, see the map perfectly, like all the coastlines and the countries there. So this is the data visualization I have done for our project, Professor.
Hey, Professor, we learned a lot in this subject. Thank you for providing an opportunity to work on data analysis.
Congratulations on your baby. Merry Christmas, Professor.